Welcome to Session 5 on Interactive Teaching and Active Learning. In this session, we will first have an introduction to this session, then discuss the benefits of one-on-one teaching and active learning methods that can be incorporated into your own classroom. These active learning methods are grouped into 3 categories of activities: those that will take less than 2 minutes, those that will take 2 to 5 minutes, and those that will take 5 to 20 minutes of your class time. We're going to learn how to juggle in this session. There's an important equation that describes juggling that will be helpful for us to know while learning how to juggle. This is the equation. F plus D times H equals V plus D times N. In this equation, F is equal to the time a ball is in the air, D equals the time a ball is in a hand, V equals the time a hand is vacant, N equals the number of balls, and H equals the number of hands. Now that we have covered the equation, let's juggle. Here's Brandon, our first volunteer. Have you studied the equation? Okay, let's see. Maybe you should go sit down and study some more. Let's have another volunteer. Here's Barry. Hopefully he's studied a little bit more.
Oh, definitely.
Oh, there you go. Clearly you did a good job studying. All right, why did I show you the slide about how to juggle? Often when we teach, we expect that students will be able to do things as a result of our teaching. This is especially relevant in the sciences, but does apply to other fields too. However, the way that we teach may not really support students' retention and transfer of the information from our classes to another class or to real life. In this session, we are going to discuss how we can adjust the methods used in our classrooms to help students' retention and transfer of knowledge. Ronald Burke, in the book Professors Are from Mars, Students Are from Snickers, says that students learn 10% of what they hear, 30% of what they see, 60% of what they hear and see, 80% of what they hear, see, and do, and 100% of what they hear, see, do, smell, feel, taste, and purchase on credit. Students learn more effectively when all of their senses are engaged. In this session, we will discuss how we can incorporate active learning methods to engage students in the learning process. The goal of this session is to illustrate how to incorporate various active learning techniques in a course to increase students' understanding and ability to transfer knowledge to new situations. The learning objectives for this session are that by the end of this session, you will have considered ways to 1. Apply relevant research on active learning to your teaching. 2. Discuss the impact of active learning exercises in the classroom and evaluate the time requirements for different active learning strategies. And 3. Develop activities and/or techniques that will help students achieve the learning objectives in your course. Let's have a discussion now to share the type or types of interactive techniques that you've encountered, either as a student or as an instructor yourself. Share your experiences on the online discussion forum. Be sure to also include an analysis of the pros and cons of those interactive techniques. Pause the video now while you share your experiences. Benjamin Bloom did seminal work on assessing the effectiveness of different classroom teaching strategies. In this study, he had 3 groups of instruction. In the first group, called Conventional Learning, there was 1 teacher for 30 students. In this group, regular tests were given and feedback on student performance was provided to the students. In the second group, called Mastery Learning, there was also 1 teacher for 30 students. In addition, the teacher was often the same teacher as in the first group. The only difference in the Mastery Learning group was that feedback given on tests was followed by corrective procedures, and another test was given to make sure that students mastered the subject matter. In the third group, called the Tutorial group, there was 1 teacher for 1 student. The teacher is sometimes called a tutor. It's important to point out that the students weren't receiving extra instruction, but rather they were working directly with 1 teacher to learn the material. In this group, students learned the subject matter with a good teacher. They were given regular tests with the same feedback and corrective procedures as in the Mastery Learning group. Following instruction in each of these learning groups Bloom then assessed how well students in each group performed on a specific summative assessment. The x-axis of this graph represents the summative achievement scores, and the y-axis represents the number of students. When Bloom analyzed the scores of the students, he found that they received a wide range of scores that followed a typical bell curve distribution. Bloom found that the average student in the Mastery Learning group performed better on the final assessment test than the average student in the Conventional Learning group. Benjamin Bloom found that the average scores of the students in the Mastery Learning group were 1 standard deviation above those of the Conventional group. When Bloom analyzed the achievement scores of the students in the one-on-one tutorial learning group, he found that the average student in the one-on-one learning group performed even better than the average student in either the Conventional or Mastery Learning groups. In fact, the average student in the one-on-one tutorial learning group performed 2 standard deviations above the average student in the Conventional Learning group. Even more astounding is that the average student in the one-on-one learning group performed above 98% of the students in the Conventional Learning group. The most striking result of Bloom's data is that most students have the potential to reach a high level of learning when they learn in a one-on-one instruction method. Bloom then focused his attention on finding other strategies that could mimic the striking 2 sigma effect of one-on-one teaching for group instruction settings. Now we'll have a brainstorming session on why one-on-one teaching is so effective. Why do you think that one-on-one teaching is so effective? Pause the video here while you brainstorm a few ideas. Here is a brief list of the reasons that you may have come up with. One-on-one teaching is so effective because the teacher can provide instruction that is perfectly tailored to the student's needs. The teacher can gauge the student's understanding of the material and ask questions to the student to guide the student's learning process. The teacher can provide a safe learning environment in which the student feels comfortable and able to ask many questions. In addition, the teacher can provide immediate feedback to the student, which ensures that any misconceptions are corrected before continuing with the lesson. This brings up the question of why can't we tutor everyone? It's important to understand that one-on-one teaching methods are expensive, lack social interaction with peers, and the quality of instruction can vary widely depending on the teacher's abilities. For the rest of this session, we will talk about how we can mimic aspects of one-on-one teaching in a classroom setting to increase retention and transfer of knowledge. Let's discuss how we can incorporate active learning methods as a means to incorporate some of the benefits of one-on-one teaching into a classroom setting. We will be using the term active learning in this session. According to Richard Hake, active learning is defined as an interactive engagement of students in heads-on, always, and usually hands-on activities, which yield immediate feedback through discussion with peers and/or instructors. Heads-on refers to students actively thinking during the lesson, and hands-on means students are doing things to help them learn the material. When we talk about active learning, we are referring to students thinking, writing, predicting, calculating, and classifying information on their own. By just getting students to write or think about the course material, students are actively learning. When students learn interactively, they may start with active learning, but will go on to discuss, persuade, collaborate, and argue with their peers. These interactive learning methods can be built into a course as a course progresses, and this strategy is recommended for a course in which students may not have previously encountered interactive learning methods. For the remainder of this session, we're going to call both of these categories active learning. Richard Hake demonstrated that courses that incorporate active learning have increased learning gains. He performed a study to analyze learning gains of approximately 6,000 students in high schools, colleges, and universities across the United States that were enrolled in physics courses taught with either a traditional lecture or interactive engagement format. To assess learning gains, students took a physics concept test called the Force Concept Inventory prior to and after learning physics. The x-axis of this graph shows the average percentage score on the pretest, or the test that is given at the beginning of the course. The y-axis of this graph shows the percent learning gain, which is the difference in the average post-test score and pre-test score of each course. The data points that are plotted on the graph represent the average of all the students in a course. For example, if a student received an 80% on the pre-test, then the student can have a maximum learning gain of 20%. The maximum possible learning gain is indicated by the diagonal line going through the center of the graph. Hake found that the students in the traditional lecture courses, which are indicated by the red data points, had a maximum learning gain of 0.23. Students in courses with interactive engagement, which are indicated by green data points, achieved higher learning gains of 0.48, which are almost 2 standard deviations above the learning gains in traditional classrooms. In fact, all of the courses with interactive engagement had higher learning gains than traditional courses. In this data, the traditional lecture courses were taught by both excellent and poor teachers. This demonstrates that the instructor ability does not account for the lower learning gains. Instead, the method of instruction accounts for the higher learning gains found in the courses with interactive engagement. Now we're going to talk about specific active learning methods that can be incorporated into your own classroom. These methods have been grouped into 3 categories based on the amount of time they will take during your lesson. There are activities that will take less than 2 minutes of class time, those that will take between 2 and 5 minutes, and those that will take between 5 and 20 minutes of classroom time. These groupings are arbitrary, but they are useful when planning the length of time that the activities will take in your class. In all of these methods, it is important to think about how the activity will help your students achieve your desired learning objective and its corresponding level of Bloom's taxonomy. First, we'll discuss activities that take less than 2 minutes to complete. The first type of short activity is simply asking your students if they have any questions. When doing this, it's important to do 2 things. First, think about the phrasing of the question that you use. By asking, "Do you have any questions?" you will create an open environment in which students will feel comfortable asking a question. The second thing that you, as the instructor, should do is wait for a sufficient length of time after asking the question. By waiting, you will demonstrate to your students that you would actually like to receive questions. Pause for at least 10 seconds. This will be a sufficient length of time for your students to think of a question and in some situations gain the courage to ask the question and then raise their hand. Let's see how long 10 seconds feels. Okay, ready? Go. Okay, that was 10 seconds. 10 seconds feels like a really long time. As the instructor, I usually count to 10 really slowly in my head to make sure that I wait long enough. Another strategy is to take a sip of water or erase the board while you are waiting. It is very important to wait at least 10 seconds. I can't tell you how many times a student has raised their hand once I have counted to 9 in my head. The second type of short activity is to pose a question to your students and give them time to think of the answer. This type of activity is similar to the first one in that the instructor will need to provide a sufficient length of time for students to think about and answer the question prior to collecting the responses. The amount of time that the instructor waits will depend upon the question's difficulty level. The last type of short activity is a mud card. You have already encountered these cards at the end of each session. The mud card is a method in which instructors can ask students to write down the muddiest or most unclear point from the session. The mud cards are typically handed out at the end of each class, and students have 2 minutes to complete the mud card. Following the class, the instructor can skim through all of the mud cards very quickly to identify the most common misconceptions, and then these misconceptions can be addressed at the beginning of the next class. In this manner, the instructor will ensure that any misconceptions are clarified prior to continuing with the course material. Now let's go through several examples of brief, active learning activities that will take between 2 and 5 minutes of class time. All of these activities are examples of quick thinks from the paper by Cooper et al. Called the Interactive Lecture. In a compare-contrast activity, students are asked to identify the similarities or differences between 2 items or concepts. When providing a reorder the steps activity, An instructor may ask the students to place all of the steps of a particular laboratory procedure in the correct order. In other quick thinks, students may be asked to provide supporting evidence of a statement, explain a conclusion based on provided data, rephrase an idea in their own words, fix a mistake, or correctly complete a sentence. The last activity, Select the Best Response, is a multiple choice question in which students are asked to identify the best answer to the question. In all of these activities, students first work on the activity on their own, discuss their answer with a peer, and then share their answers in a whole class setting. This type of think, pair, share activity helps to engage students in the learning process. As I just mentioned, the most effective manner to incorporate in-class concept questions is through the use of think, pair, share activities. In this type of activity, it is important for the instructor to gauge the level of each student's understanding in the class, and not just that of the high-performing student who is able to answer the question quickly. To be most effective, it is important to obtain answers in an anonymous manner to ensure that each student provides his or her own response to the question. In addition, it is important to have a method for the instructor to quickly and accurately gauge the level of understanding of each student in the class. The best concept questions contain multiple plausible answer choices. These types of questions will generate discussion among students. This will engage students in the course material and promote interactive learning. By listening to these discussions, the instructor will be able to identify student misconceptions about the course material. It is important to remember that when concept questions and active learning methods in general are implemented well in a classroom, students overwhelmingly support their use. One way of incorporating concept questions and collecting student responses is through the use of clicker response technology. Clickers are small, remote-like devices on which students can select their answer. Each student's answer is relayed to a receiver on the instructor's computer, and the number of student responses for each answer choice is displayed for the instructor. If you choose to use technology in your classroom to collect student responses, be sure to inform your students of the reasons of doing so. While clickers are one method of obtaining fast, anonymous responses from your students, there are other methods as well. One method is to have students hold up color-coded paper cards to represent their answer. Each card represents a different answer choice. Another alternative to clickers is to have students hold up a different number of fingers in front of their chests to indicate their answer. In this case, one finger can represent A, two fingers can represent B, etc. In all of these cases, whether technology or non-technology based, the instructor can easily determine the approximate percentage of each answer by scanning the classroom or computer screen. In the case of the non-technology methods, each student's answer will remain anonymous to their peers if the students hold up the cards or their fingers in front of them. By providing their answers in this manner, students won't be persuaded to alter their responses based on peer pressure. Let's try doing this method of feedback using an online, web-based system to collect answers on several concept questions. Navigate to m.socrative.com and join room number 202247. This system lets you provide answers in a web browser on your computer, tablet, or mobile phone. Writing good concept questions is a difficult task. Let's go through several different types of concept questions. All of these examples will fall under the Select the Best Response category of questions. The first question is, when did World War II occur? A, 1914 to 1918, B, 1939 to 1945, C, 1941 to 1945, or D, 1950 to 1953. Use the online system to provide your answer to the question. Pause the video now while you answer the question. Go to the online discussion forums to discuss your answers. Pause the video now to discuss the answer. Now that you have had a chance to discuss your answers, answer the question again in the online system. Pause the video here while you answer the question. The answer to this question is B, 1939 to 1945. What level of Bloom's taxonomy does this question represent? Pause the video now while you think about the answer. This question focuses on remembering the particular dates of the Second World War and corresponds to the lowest level of Bloom's taxonomy. When designing concept questions, it is important to design thoughtful questions. It is important to be thoughtful about what you ask and why you are asking the question to ensure that the question will help your students attain your desired learning objective. Students overwhelmingly see challenging questions as the most useful for their learning. Let's answer the second example question now. If living cells similar to those found on Earth were found on another planet where there was no molecular oxygen, which cell part would most likely be absent? A, cell membrane, B, nucleus, C, mitochondria, D, ribosome, or E, chromosome. Use the online system to provide your answer to the question. Pause the video now while you answer the question. Go to the online discussion forums to discuss your answers. Pause the video now to discuss the answer. Now that you have had a chance to discuss your answers, answer the question again in the online system. Pause the video here while you answer the question. The answer to this question is C, mitochondria. The mitochondria are one type of organelle within cells that are responsible for generating most of the cell's energy in the form of ATP through the process of cellular respiration. What level of Bloom's taxonomy is this question? Pause the video here while you think about the cognitive level of understanding that is required to answer this question. This question is at the understand level of Bloom's taxonomy. Students are required to be able to explain the function of each of the parts of the cell provided in this question and understand that the mitochondria use oxygen to complete their function. Let's go through another example of a select the best response question. Consider a drug, HA, that is active only in the deprotonated A- form. The pKa of the drug is 4.0 and the pH of blood is 7.4. Select the correct statement below. Most of the drug will be in the active A- form in the bloodstream. Most of the drug will be in the inactive HA form in the bloodstream. The ratio of A- to HA will be approximately 1:1 in the bloodstream. Or D, more information is needed to predict the ratio of A- to HA in the bloodstream. Think about the answer to the question on your own, and then use the online system to record your answer. Pause the video here while you answer the question. Go to the online discussion forums to discuss your answers. Pause the video now to discuss the answer. Now that you have had a chance to discuss your answers, answer the question again in the online system. Pause the video here while you answer the question. The correct answer is A. Most of the drug will be in the active form in the bloodstream. The pKa is the point at which the molecule will lose a hydrogen atom. As a result, if the pKa is 4, then the drug, HA, will have lost the hydrogen atom in the bloodstream, which is at pH 7.4. This select the best response question is a great example of a question that can provide essential feedback on how well students understand the concept. The instructor can assess student understanding based on the percentage of correct answers and also by analyzing how quickly students can solve the problem. Let's go through one last example question now. Based on research at NASA, What was the approximate net global change in temperature between 1880 and 2000? A, plus 2 degrees Celsius, B, plus 0.7 degrees, C, plus 0.05 degrees, D, minus 0.05 degrees, or E, minus 0.7 degrees Celsius. Think about the answer to the question on your own, and then use the online system to record your answer. Pause the video here while you answer the question. The correct answer to this question is B, plus 0.7 degrees. I could use this question as an attention getter for a class on global warming, temperature measurements, or the politics of global warming science. In this case, the question serves to engage students in the material that I'm about to present and provides motivation for learning the material. In most of these example questions, we provided prompts for you to implement using a think, pair, share strategy. Data by Smith et al. Demonstrated that peer discussion, when implemented with clicker technology to answer in-class concept questions, is effective at improving student performance on the concept questions. The use of peer discussion is effective, even when all of the students in the small group do not understand the question correctly at first. As a result, when implementing effective concept questions in your own classroom, allow for peer discussion periods following an initial period for students to think on their own. Now let's go through activities that will take longer to implement during class. These longer activities usually take between 5 and 20 minutes of class time. They are either activities that contain long discussions or demonstrations centered around answering multiple choice or open-ended questions, or activities that involve participation of the whole class. All of these longer activities are usually reserved for concepts that are especially challenging to teach and are formatted to promote whole class discussion and participation to engage all of the students in the class. Let's go through an example long activity now. This is an example demonstration that could be incorporated into a physics course. In this demonstration, I have 2 wooden blocks. They are made out of exactly the same type of wood and are exactly the same length and width, but they vary in their thickness. One block is twice as thick as the other, the thin block. Now when I tap on the thin block, it makes a specific tone. Let's do this now. Could you hear it? Now my question is, if I tap on the thicker block, will the tone be higher than, lower than, or the same as the thinner block? Pause the video now while you answer the question. Go to the online discussion forums to discuss your answers. Pause the video now to discuss the answer. Now that you have had a chance to discuss your answers, answer the question again. Pause the video now while you answer the question. At this point, if I were performing this demonstration in a real classroom, I would ask for students to provide their answers to me and a short explanation of their answer. I would record their answers on the board. It is important to simply write all of the answers, whether they are correct or incorrect, on the board without giving away the answer. We will skip this step in this online video session, but I encourage you to include this step in your own classrooms when you're implementing long activities such as this one. Now let's find out the answer to the question that I posed at the beginning. To remind you, I have 2 blocks that are the same length and width. They only vary in their thickness. And when tapped, the thin block has a particular tone. Let's tap the thin block now. Okay, now listen carefully while I tap the thick block. And again, we'll do both of them. What did you hear? The thick block has a higher tone than the thin block. The thick block has a higher tone than the thin block by almost a factor of 2, because the thick block is stiffer than the thin block. At this point, I would review the answer with my students. The frequency of the tone is approximately equal to the square root of the stiffness coefficient K over the mass m. The stiffness coefficient is proportional to the thickness of the block cubed, and the mass is proportional to the thickness of the block. As a result, the frequency is proportional to the thickness of the block, and the frequency of the tone of the thick block is almost twice as high as that of the thin block, because it is twice as thick. Now that we have completed the demonstration, let's think about the way in which the demonstration was implemented in the classroom. What were the teaching elements of the demonstration? And why was the demonstration performed in this manner? Pause the video now to think about your answers to these questions. The demonstration was performed in a very specific manner. After introducing the demonstration, students were provided a sufficient length of time to think and then answer the question on their own. Students discussed their answer with a peer and were able to answer the question again. At this point, the instructor could then collect answers from several students in the classroom and write them down on the board. Then the actual demonstration was performed, and hopefully the students had an aha moment. At this point, the demonstration was reviewed and the answer was explained. The demonstration was performed in this manner for specific reasons. First, I asked for student predictions about the demonstration before students knew the conclusion to the demonstration. In this manner, I hope that students will be more engaged in the demonstration as they are vested in the outcome. Research by Professor Eric Mazur at Harvard University showed that demonstrations are only effective when students are asked to predict the outcome of the demonstration prior to it being performed. If students were not asked for their predictions, then the demonstration was no more effective than a lecture on the concept at hand. Second, there is a moment for students to interact with each other and discuss their answers. In this manner, students are participating interactively and are arguing and persuading each other of their answers. Then, at the end, I performed the actual demonstration and reviewed the answer to ensure that the students understand the concepts in the demonstration before proceeding with the course content. Now I will review 2 more example long activities to demonstrate other types of activities that can be implemented in your own course. The first activity is an example of an open-ended brainstorm activity. In this activity, students are presented with a particular case study and are asked to think of solutions. In this case, the head of hammers made by a particular manufacturer are failing. Students will work together in small groups to determine why the hammers are breaking in this particular manner and what can be done to prevent this from happening in the future. Students will work to determine the necessary information and tests that will need to be performed to make a full recommendation to the manufacturer. After providing sufficient time for students to work on this activity, the instructor can then collect the responses in a group brainstorming session or through short presentations by each group. This next activity is an example of a whole class participatory activity. It models vacancy diffusion in a class that is teaching about solid-state diffusion. In solid-state diffusion, 2 different metals, after being heated, are mixed across a boundary between the 2 metals. And there are 2 types of diffusion that can occur. First, interstitial diffusion, in which diffusion does not occur on a lattice framework. And second, lattice diffusion, in which diffusion does occur on a lattice framework. To implement this activity in your course, first create a grid on the floor. Divide the class into 2 equal groups and assign one half of the class to be one color and the other half of the class will be a second color. Each color represents one of the types of atoms that will diffuse. Each student is then assigned a number that will determine when each student can move, and the students are then tasked to find a spot on the lattice. At the beginning of the activity, all students representing one type of atom are assigned to one side of the grid, and all of the other students representing the other type of atom are on the other side of the grid. As the instructor then calls off the numbers in order, each student has to move to an empty spot or vacancy if there is an open spot as their number is called. Students are allowed to move forward, backward, or side to side, but not diagonally. The instructor will likely have to call out all of the numbers several times, perhaps even up to 10 times with 40 students. At the end of the activity, the students will have demonstrated vacancy diffusion with their own bodies and see that there is an equal mixing of the two colors or atoms across the lattice. Let's do an activity where you will have the opportunity to think of how particular active learning strategies can be used in the classroom. For this activity, use the Active Learning Strategies handout that can be found on the course website. If possible, complete this activity with one other person. First, identify 2 active learning strategies on the handout, and then discuss for each active learning activity, first, how you will integrate the activity in a course to facilitate teaching of a specific learning objective. Second, the time requirements of the active learning activity. And third, the potential pros and cons of the activity. Once you are done, share your findings on the discussion forum of the course website. Pause the video now while you complete this activity. Now let's complete an activity where you will have the opportunity to think of an active learning strategy that you would like to use in a class that you teach or would like to teach. First, think of one of the learning objectives that you wrote in the session on designing a course. What active learning strategies could you use to help your students achieve that learning objective and provide you and your students with information about whether they attained your learning objective? Then, think about the pros and cons of this active learning strategy. Once you have had a chance to complete this on your own, share your active learning strategy with a peer, and then select one of your active learning strategies to share on the online course discussion forum. Pause the video now while you complete this activity. In this session on interactive teaching and active learning, we discuss Benjamin Bloom's seminal work on the benefits of the one-on-one teaching method and how the incorporation of active learning methods in the classroom can engage students to ultimately increase retention and transfer. We also discuss the incorporation of active learning methods in your own classroom, such as posing a question and mud cards that take less than 2 minutes of classroom time, quick think methods that take between 2 and 5 minutes of classroom time, and longer activities, such as demonstrations and participatory activities that can take up to 20 minutes. At the end of the session, you had the opportunity to participate in activities to develop your own active learning strategies for your own classroom. Do you have any questions or comments? Take a moment to write any lingering questions or comments that you may have on the discussion forum. The post-session assignment for this session is to describe how you will use specific interactive techniques to advance 3 of your learning objectives that you developed in a previous session. Be sure to specify details on how the activity will be incorporated into your course. Please see the instructions on the course website for more information on this assignment. Immediately following your viewing of this session, please complete the online survey for the mud card.